All right. So let's discuss this assignment. We did the guided notes yesterday. There's a PowerPoint for that. The questions I want to discuss. First of all, there were a few students who were a little confused about number 3 as to how to answer that. If you guys could pay attention to that, number 3, which is on page 3. The question number 3 on page 3. It says for the following pair of wires, choose the wire that has the greatest resistance. The resistance to charge flow will be greatest in, circle the best answer. So the way you're comparing these is, so for A, in that pair, a wire which is thin, a wire which is thick. Out of these two, which one is true? You pick one. Austin, I think you asked me a question, right? So I don't know what I answered yesterday, but when I looked at this question, that's how you do that, right? So either it's the thick wire or the thin, right? And then out of the second one, a wire is long versus short.
Yeah.
That's how we do it, right? All right. And that's the type of the same type of question you're going to encounter in number 5, where it refers to the gauge of the wire. Notice that it does give you the diameter. The gauge goes as 1 over the, it says 1/12 of an inch. That's what a 12 gauge means. 1/12 inch diameter. But anyways, let's look at number 7. That's the one I really want to discuss. Okay. This is the type of question we dealt with something like this when we did Coulomb's law. It involves a slightly different type of reasoning. It's a different approach than, you know how people talk about the plug and chug type thing, which majority of the algebra deals with those type of problems at high school level. This type of problem involves a little bit of a different reasoning where you don't directly plug and chug, but you're given a relationship, a formula is known to you, and you're figuring out that in that relationship, if you changed one of the variables, let's say you doubled it, tripled it, or decreased by a factor of 2, how will that affect the other variable? Okay, that's that type. Remember, we did this type of thing for Coulomb's law, and you guys also did some concept builders. So here we go again, we're going to see the same type of thing here. So this problem deals obviously with the relationship between, as you can see by reading it, current, voltage, and resistance. So what's that relationship? There's a name for it. It's called Ohm's law. And the relationship is expressed as the formula I equals delta V over R. Physics is all about studying relationship between different variables, right? So that's one of them. So now according to this relationship, again, you're going to be asked, first, ignore for a second this thing. It tells you that what's the current in the circuit. But the idea is that in this relationship, let's say that if the resistance increased by a factor of 2, if the resistance increased by a factor of 2, what would happen to the current? Would it increase by a factor of 2, decrease? In other words, would it double, triple, half, quadruple? What would be the answer? That's what's that. So let's first do that. It's actually asking a little bit more than that. So look at the formula. Again, I'm going to remind you how to approach these type of problems. Look at the formula and use this method that will help you reason. According to the formula, okay, if the resistance is increased by a factor of 2, notice that it doesn't say delta V, which is the voltage has changed. The variable that doesn't change, just keep it as a 1. Just think of that as a 1. Okay, put a 1 there. The R has increased by a factor of 2. It's doubled. Put that 2 where R appears, which is in the denominator. So this is the factor by which the current, this left side, the current will change. In other words, the current will be half times its original value. The original value of the current is 8 amps. So your answer will be half times 8, which is, the answer is 4 amps. Let's try another one, which may not be in this one, so that you get practice. And I'll ask you guys all to maybe send an answer through the chat. Tell me what would happen if the voltage decreased by a factor of 2 and resistance increased by a factor of 2. So voltage, when I say decrease by a factor of 2, the decrease by a factor of 2 means voltage has become half its value. And I'm saying that the resistance has increased by a factor of 2 times 2. That's times a half. So by what factor would the current change? Is it going to double, triple? You want to send me the chat message so that I can see, give others a chance to figure it out too. This type of reasoning is actually something pretty good to know how to do. It's all over the place. You can apply this technique to any formula. Okay. Let's see. So think again, Casper. So delta V has halved. And then R has increased by a factor of 2. Anyone else? Come on, folks. Let's see what you got. You did more complicated stuff. The Coulomb's law was way more complicated. It had an R square at the bottom. That was a distance, by the way. This is resistance. But the idea is, the reasoning is the same. Yeah, I'm waiting on people to send me a chat answer. All right, those of you who have answered, try again. I'll let you know if somebody got the right answer. Again, think about it. Where voltage appears, delta V is the voltage. That's where the factor for voltage goes. Where R appears, that's where the factor for R goes. If the two things divide, the factors divide, right? If the two things multiply, the two variables, then the factors multiply. And there's no R square or anything. Don't think like it's the formula as in Coulomb's law. This is a different formula. Come on, folks, give me one correct answer. I haven't seen so far. Don't give me the current, by the way. I'm just asking you by what factor. Ignore the 8 amp current. Nope. So far, nope. All right, let's discuss this. That means everybody needs to pay attention then. Okay. Again, look at the formula. Let the formula guide you. Delta V is at the top. Delta V has changed. It's decreased to half its value. That's what it means to decrease by a factor of 2. The resistance has increased by a factor of 2. Resistance is at the bottom. That's where you put that 2. What's half divided by a 2? Exactly. This 2 ends up down here. It's 1/4. So the current will be 1/4 its original value. I think you were thinking along the right way, but you just, the math part, I think. And what's 1/4 of 8 amps? It's 2 amps. The current will actually be 2 amps. So it's 1/4, but I'll give you another chance. All right. Times 8, 2 amps. All right, let's do another one, and then I'll let you. All right, let's say that, okay, ready? So the voltage, let's say, increased by a factor of 3, and the resistance decreased by a factor of 2. In other words, times a half. By what factor? Don't worry about the 8 amps right now. By what factor, in the chat, tell me, will the current change? It could be a fraction, it could be a whole number. On the test, I'm going to be throwing these type of problems for this as well as Coulomb's law. So let's try to understand it now. All right, let's see. Casper, you got it right. The second one. Yep. I guess the previous one was the good. Nick, can you do me that calculation? You're right there. You wrote it right. Give me the, tell me what that's going to be. Aiden, you got it right. Good job. So now you guys are getting it. If you're ever not sure about how to deal with dividing with a fraction or multiplying, use your calculator. Nick, you got it right. Ben, think about it again. Tyler, think again. Again, I'm just interested in the factor by which the current is going to change. Don't worry about the 8 amps yet. Cody, correct? Anyone else? All right, I'm just going to show you now again because I want to move on. Again, look at it. When people say someone is smart, this is really what it means. You just have more ways of reasoning about things. The larger the variety of things, the ways you can reason, the smarter you are. It's nothing to do with some, there are very few people who are those born geniuses. Most of us have to work through this. But so delta V, the top part is 3. And you're dividing it by R appears in the denominator. That's where you put its factor. 3 divided by a half. When you divide by a fraction, you multiply by its reciprocal. In other words, this 2 here ends up there because you're kind of double dividing. So 3 times 2 is, I'll just put it in one step, 6. So the current will be 6 times larger, and 6 times the 8 amps is the actual value of the current. So then that would be, the answer would be that. By the way, I messed up one thing. This here, let me see if that's the resistance increased by a factor. No, that is with that. Sorry, I thought maybe I put these answers there. But anyway, that's just a side thing. So got the idea, right? That's how you're going to do this part. Okay. Number 8. Number 8 is different. Number 8 is the plug and chug type problem, where you actually read this. I'm going to do one part for you because I feel like I've noticed some people were a little confused with the algebra here and there. Let's do part C together, and 8. So in this type of a problem, you're actually given the values of the variables. Okay, it's not that type of reasoning other type. It says an electrical device with a resistance blank, in other words, question mark ohms, has an electric potential difference of 120 volts. So you're given delta V. That's the 120 volts. And you're told that the current in the device is 6 amps. So I is 6 amps. So the question is, what is the resistance, right? Blank, this symbol here, that is the unit of resistance. So what is the resistance? This is the plug and chug. So you look at your Ohm's law, I equals delta V over R. Plug into that. I is 6. Delta V is 120. Divided by R is unknown, so keep it as R. How do we solve this? You can do it in 2 steps, or if you want to do it in 1 step, I'll show you a quick way of doing this. No need to waste our time. So typically people will cross multiply, right? And then they will first cross multiply, then they'll divide both sides by something 2 steps. I want you to just remember one rule in algebra. Anything that you can cross multiply, you can also swap. And you pick, you don't have to swap everything. But for me, when I look at it, I can cross multiply these. So 6 and R can multiply. I can swap them too. I want the answer for R. I want R on the left side. So why don't I swap that with 6? So I get 120 divided by 6. Did you see how I swapped the 2? So I cut out 1 step. As you get better, look for shortcuts, all right? But first, you got to make sure, you don't take shortcuts when you're still fuzzy about your algebra, because that can lead to a lot more confusion. So 20 ohms is the answer. The resistance will be 20 ohms. In the other 2, you will be given 2 of the 3 variables, and you figure out the third one. It may be, in one, I think you have to calculate the current, in the other, voltage, and that's it. The other thing I wanted to discuss, this is basically the same type of a problem, where you're given a circuit, and you can see that in this circuit, it's a single loop. Notice that you're given one of the currents. Do you guys remember from your lab Like how will this current, is this going to be smaller than, equal to, or greater than 4 amps? If you have one single loop circuit, the current throughout the circuit, exactly. It's the same everywhere, in the battery, through the resistor. If it's just a single loop circuit, remember current is not being used up, right? The only time the current is different is if there's a junction that splits between two branches, like in a parallel circuit. We'll come to that later. So all you got to do is just write 4 amps is already written, so you don't need to do that. Now that you know the current through the resistor and the voltage, if you only have one resistor, then the voltage across the resistor is also 12, the value. Tomorrow we're going to discuss it's actually negative 12, it drops, but the absolute value is still 12. So can we calculate, first of all, the resistance? All you got to do is use the formula I equals delta V over R. Plug in your I being 4, delta V being 12, and solve for R. So the rest, I'll let you do that. In this one, you're working out the resistance again, and you're figuring out the voltage. As I discussed, if there's only one resistor, all the energy that the charges have is usually, when they go through the resistor, they kind of use up, that resistor gets to use that energy, it uses up that energy. So that would be 12 volts, same as battery. If there were two similar resistors, then the voltage splits, okay? If there were 3 resistors, it splits equally between 3. If the resistors are equal. If the ohms are different, then it'll be a different split. That's the type of stuff we're going to do next. All right, so now I'm going to let you guys finish this. Let me stop this recording, and I will post this recording in case anybody needs to